Okay, guys, here we go. It's the middle of the day, so I'm fresh, so that's good because we have a lot to cover. We are going to talk about Pythagorean theorem, special right triangles, trig ratios, inverse trig ratios, solving a right triangle. It's going to be, and even some reciprocal trig ratios. So this is one of my favorite parts about geometry, and I already know that this video is going to be a bit much. So just keep in mind that it'll be saved for you and you can refer back to it. So if you don't get everything in this 1 week, which is, it's a lot, it's okay. Okay, so let's begin with hopefully something that we all remember. We love the Pythagorean theorem. Says that if a figure is a right triangle where the side lengths are A, B, and C, such that C is the hypotenuse, then A squared plus B squared equals C squared. Okay, so we want a right triangle. So Michael is building a slide for his kids. Good job. If the ladder is 1 meter tall and he wants the bottom of the slide to be 2 meters from the ladder, how long does the slide need to be? So right away, I know that the slide, it's like that, right? That is your hypotenuse. So I said earlier that geometry is cool because, where's the H? There's you can draw a picture for everything. So we can draw our little ladder. We can draw our slide. And then it even gives us information about how far the base of the ladder is from the slide. So this is our ladder. So step 1, draw a picture. Slide or a diagram. So the ladder is 1 meter tall. 1 meter. He wants the bottom of the slide to be 2 meters from the ladder. 2. How long does the slide need to be? Okay, well, this is A, B, and C. C is just the hypotenuse. Across from the right angle is the hypotenuse. So now we know A squared plus B squared equals C squared. So A is going to be 1 squared plus 2 squared equals C squared. So 1 plus 4 equals C squared. C squared equals 5. And to inverse operate, you got to square root both sides. So C is equal to the square root of 5. And, Michael probably doesn't want you to tell you the square root of 5. He probably wants to know, what is the square root of 5? 2.4. That's what I think. 2.24. All right. 2.24 approximately. So we want that slide to be 2.24 meters. All right, so then, we draw a picture. We put the given information where it goes in the picture, substitute it into the theorem, solve, and then get our answer. And don't forget to know what your answer means. So this, let me just write it down to prove to you I know this is the length of the slide. All right, moving on. That should make you feel comfortable, and now I make you feel uncomfortable with these special right triangles. So the reason is because now we only have 1 side length. In special right triangles, you only need 1 side length, and then you can determine 2 side lengths because of these angles. There's special angles. It doesn't work for any angles, but in special right triangles, you know what? I should take that back. I mean, we're going to do trig, and then you'll see, oh, it does work for any angle you just said. But there's only 2 special right triangles. That's what I mean. And so they are 30, 60, 90. Write it down. And the second special right triangle is even easier. 45, 45, 90. These are degree measures. Okay, so if you have those angles in a triangle, it is a special right triangle. And there's some reasons why, but I'm just going to show you the formulas right now, and you can ask me in class why, and then I'll tell you. I'm going to withhold that information from you and just write down the formula. So in the 30, 60, 90 triangle, we have 3 different side lengths. I like to say the small, the medium, and the large. The small side is x, and this is the small side. The medium side is √3 times x, but we write the x up front so we don't think it's underneath the radicals. X √3, so that is the medium side. And the large side is 2x. So whatever the small side is, the large side is double. And you might say, Mr. Field, how am I supposed to know which is which when I don't know the side lengths? And that's a good point. The way you know is by looking at the angle. So the small angle across from that is the small side across from that. And then the large angle, 90 degrees is the largest angle, and it's across from the largest side. And so 60 is the medium angle, and it's across from the medium side. Oh, so yeah, 2x for the large, right? Okay, so we're going to use that little formula. And I'll show you a shortcut right now, too. So, yeah. Okay, so the 45, 45, 90 is a little bit easier. It has 2 sides that are the same. Why are the sides the same, Mr. Field? Because it has 2 angles that are the same. So they're both x and x. And then the hypotenuse is x times the square root of 2. All right, hold on. I'll be right back. All right, so we have our special right triangle formulas, and now we're going to use those to find our other sides, the missing sides. So in this first triangle, it is what type? 30, 60, 90, or 45, 45, 90. Well, you can see 30, 60, 90. All right, so we're going to use this one. Next step, which side do we have? Well, this is across from the medium angle, so it's the medium side. Okay, so that formula here is x √3. So we know that x √3 equals 4 √3. So after you can set up the equation, and then you can solve for x. So how would we solve for x? We divide both sides by √3, so 4 √3 over √3, and then it's 4. It's just 4. X equals 4. All right. So you might not need to set up the equation for everyone, but if you get stuck, you can. So then the hypotenuse is 2x, so we know that x equals 4, so 2x is 8. Didn't have to set up the equation for that. All right, now there are some more difficult ones, so I just want to show you that. Let's say that we had the medium side was 10. Or maybe let's make the medium side 12. Okay, so now we want to know what are these guys. Okay, so we know that x √3 equals 12. So then we divide both sides by √3, and we get x equals 12 over √3. But that's not really the way it's written. So there's a shortcut to write it in a rationalized way. You can just divide the 12 by 3. 12 divided by 3 is 4. So 12 √3 is the same as 4 √3. So in math, we don't really like radicals in the denominator. So again, what I did is I divided by the number under the square root sign. And you can check it in your calculator. 12 divided by √3 is the same as 4 √3. And that way we don't have radical in our denominator. So the short side is 4 root 3, and the hypotenuse would be 8 root 3, just double the 4. And I'm going to actually show you more about why that is in class, but I'm just showing you the shortcut. Divide by 3. So now here is what kind of a triangle? Well, this is a 45, 45, 90 triangle. I can see those two 45s. And I know the leg is x. So x equals 3 root 2. And so the hypotenuse is x root 2. So, okay, well, I already know x. So x is 3 root 2. So that's going to be 3 root 2 times the root 2. Okay, because x is 3 root 2, so that goes right there. And then the second root 2 is right there. So what is root 2 times root 2? That is 2. So 2 root 2's make a 2. And then that makes it 6. Okay. That's pretty neat. 3 root 2 times root 2 is 6. Okay, so, oh, and we should also label the other side is also 3 root 2. So special right triangles throw some people off, but hopefully having these little shortcuts and triangles already in your notes when you come to class will make our study of them even more fruitful. But now we're going to do some tricks. So if you want to pause the video and go try those sections from Q1 and 4, then go for it. But now I'm just going to keep this thing going and talk about trig ratios, which go for any right triangle. And in fact, we're not going to do it, but you could do trig for any triangle using the law of cosines and sines. But we're not going to go that far during the summer. But let's begin. So trig ratios, you see these 3 words. Now, it's possible being an algebra student, you are asked to buy this high-powered calculator. This is my old one from high school. And I had we have these buttons, sine, cosine, and tan. And when I was in Algebra 1, I thought, what's that? And so now we get to talk about what that is. Those 3 things are called trig ratios. And it's not sin, it's sine. This is math class. And cosine and tangent. And each one of those is a different ratio of 2 of the sides in a triangle. So please write this down, know it when you come to class. So, ka, toa. We all have heard the story of Sacagawea, who led Lewis and Clark through the Wild West. Well, SOHCAHTOA was over here, doing some famous math stuff. Maybe that's her cousin or something. SOHCAHTOA. Okay, and so S, C, and T stand for sine, cosine, and tangent. And the O, A, and H, those stand for opposite, adjacent, and hypotenuse. So those are the different sides in the right triangle. You can see right here in this problem, we're talking about A. So we're going to circle the angle that is inside parentheses. That's important because then you have to label the sides. So you should know that this is the hypotenuse because it's across from the right angle. Okay, so we know that. And then which side is the adjacent side? Well, the side you cannot draw an arrow to is the adjacent side. So I just drew an arrow. I drew an arrow to the opposite side. That makes this the adjacent side. The adjacent side is the side of the triangle that the angle touches that is not the hypotenuse. All right, So now we have the sides labeled. This thing is going to be super simple. So the sine of A is not what I'm going to start out with. I'm going to start out with the cosine of A. And the reason is because cosine is ka, adjacent over hypotenuse. And I have the adjacent side and I have the hypotenuse. So I can just write the fraction, adjacent over hypotenuse. And you see it says write it in rationalized form. So we are going to have to rationalize. So all that means is I have to multiply by whatever the square root is in the denominator. And actually, that's what I did to get my shortcut in the last problem. So when you do that, you do 26 times 5 is 130. So it's going to be the square root of 130. And then root 5 makes 5, right? So 5 times 3 is 15. So 130, the square root of 130 over 15. And so 13, 2, 5. Yeah, so that's what the cosine of A is. The tangent and the sine, that requires us to know the opposite side. But since we have two sides already, we can use our good old Pythagorean theorem to get the opposite side. So I can say that A is the square root of 26. I can say that B is x. So this is going to be our B. And I can say 3 root 5 is hypotenuse. Okay, so the square root of 26 is, or the square root of 26 squared is 26 plus x squared. And then 3 root 5 squared is going to be 9 times 5. The 3 times 3, and then the root 5 makes just 5. So that's 45. So we get 26 plus x squared equals 45. Subtract 26 from both sides. 19. Ugh, that's not a perfect square. Okay, so then we square root both sides. X equals the square root of 19. Goodness. All right, so that makes the tangent of A is going to be the opposite. Well, let's see. Tangent is opposite over adjacent. Over A. So the opposite is the square root of 19. Tan of A equals root 19 over adjacent, root 26. Rationalize by multiplying both top and bottom by root 26. And then what is 19 times 26? 494. 494. Ugh, okay, 494. And then over 26. That's what it equals. All right. So last but not least is the sine of A. Sine is opposite over hypotenuse. So opposite is root 19 over hypotenuse, 3 root 5. Rationalize the denominator. You guys are going to be the only students in the class that are like, oh, rationalize the denominator. Okay, I'm fine. Because everyone else is going to be like, this is too much. But you're probably saying that right now during the summer. Okay, so when we're rationalizing the denominator, oh, you know what? We don't have to multiply by 3, just the root 5. Less talking, more math. Okay, so 19 times 5, that's 95. Okay. So then 95 on top and then 15 on the bottom. 3 times 5. Okay, so that is the sine of A. Okay, so if you get nothing else, remember SOHCAHTOA. Remember you can solve for the missing side using the Pythagorean theorem. And remember that you can ask me about rationalizing the denominator, which is like the step that is just makes things more confusing than they need to be. Okay, so X, now we're going to do inverse trig ratios, and these are super easy. And so I'm even going to throw in some reciprocal trig ratios. Okay, so the inverse trig is also, that's on top of those buttons, the little yellow text. Okay, so the inverse trig, and I'm not going to start out with this one, is like, let's say we wanted to know the sine of 30. Okay, so what is the sine of 30 degrees? Well, we can type that into the calculator, or I am actually going to go and use Desmos. Okay, so the sine of 30 is, that's not right. I know what the sine of 30 is, and it's not that. You know what's wrong? This is in radian mode. And you don't need to know radians pretty much until algebra 2. You just barely talk about them in geometry. So whether you're on a calculator, if you're on a calculator, press mode and switch it to degree mode. Write that down. And if you're on Desmos here, then what we do is we click this little wrench, and then we switch it to degree mode there. That's what it's supposed to be. The sine of 30 degrees is 0.5. So I know that. Now you know that. The sine of 30 degrees is 0.5. That means the ratio of the opposite side to the hypotenuse is 0.5. And we know that because in a 30, 60, 90 triangle, x to x, right? So that means the 30-degree side is half of the hypotenuse. Okay, so that makes sense to us. But sometimes you know that you don't know the angle, but you know the side length, right? So let's say we know that it's, I don't know, the square root of 3 over 2. Just throwing out some special thing there. So how do you solve for x here? What's the inverse operation? It's called the inverse trig function. So what you do is we don't actually write it like this. We don't actually write that, although you can. We just write it like this. X equals the inverse sine of root 3 over 2. So you would just, on the calculator, press second sine. And that is all you gotta do. So second, so this is, this right here is cotangent of x. So you just do the inverse cotangent of, and the only thing is there's no reciprocal trig on a graphing calculator. So that makes this one a little bit more difficult. But let's see if we can do that in Desmos. The cotangent of, all right, never before have we tried this out. The square root of 3. Can we do it? Does it work? I bet it does. Hey, look at that. So if you're using Desmos, you can just type it right in. Okay, but what I want to do is tell you what in the world is cotangent. We haven't talked about that yet. Okay, so let's talk about that. In the last problem I told you about, SOHCAHTOA. And the next generation of mathematicians, they said, wait a minute, I want to discover something new. Let's flip everything. And then we can say that we discovered something. Yay. So what are these things called? So this is opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. But what is hypotenuse over opposite? Well, that is called cosecant. I know. Like, what? All right. And then hypotenuse over adjacent is called secant. And adjacent over hypotenuse is called cotangent. So we got SOHCAHTOA and we got CHOSHAKAO. CHOSHAKAO. That's the whole family there. Okay, so these are called reciprocal trig ratios. And then when you put the little -1, that's called the inverse trig. Okay, so that lays the groundwork for a good class discussion. And the last thing I'm going to show you is how to solve a right triangle. So this should be back to a little simpler time here. We're only going to do right triangles. Solving a right triangle means identifying all sides and angles. So we want to know, what are all these sides? What are all the angles? Well, 60, 90, okay. They all add up to 180, so that must be 30. So now, almost there, I solved the angles. Now I just need to solve the sides. Well, this is really easy because it's a 30, 60, 90. So if the hypotenuse is 4, I know that that's my 2x. So this is my x. And then this is x root 3. So it's going to be 2 root 3. So I'm done. CE is 2 root 3. DE is 2. And C is 30. But hey, I'm going to throw in a non-special right triangle right now. So let's say we have 3, okay, so 3, 90, and let's just say, okay, so hold on, just one. All right, it would be better if this angle was 36.86989765, but we're going to round it up to 37. And we'll get some of your decimals here. So we are going to solve, this will be our second solving a right triangle problem. We're going to get the 2 missing sides and the 1 missing angle. So let's start by getting the 1 missing angle. I'm going to add 90 and 37. 127, subtract from 180, and 180 minus 127 is 53. All right, so that's 53. Now we're going to get the 2 missing sides using trigonometry. So let's do, you can choose either angle. So let's just choose the 37. And then we're going to find, what do you want to find? Let's find this side first. So we're going to find this side first. Then which ratio do we want to use? Well, we know this side. We want to find this side. Let's label our sides and see what we have. Okay, if I draw an arrow to the 3, because that's one of my sides, that is the opposite side. And the side that I want is bordering my angle. That is called the adjacent side. And I know that because across from the 90 is the hypotenuse. Okay, so in order to solve this triangle, I need to use the correct trig ratio. So if I have the opposite and I want the adjacent, which trig ratio connects the opposite and the adjacent? Is it sine? No, that's opposite and hypotenuse. Is it cosine? No, that's adjacent and hypotenuse. Is it tangent? Yes, tangent is opposite over adjacent. Okay, so the tangent of 37 degrees is equal to the opposite over the adjacent. So now we just solve for x. So whenever I solve for x, I just put that over 1 and cross multiply. 3 times 1 is 3, and x times tan 37 is x times tan 37. And then in order to get x by itself, we divide both sides by the tangent of 37. So 3 divided by the tangent of 37, you can use a calculator for that, is approximately 3.98. So the exact value would be 3 divided by the tan of 37, but the approximate value is 3.98. And once we have two sides, then we can just use the Pythagorean theorem to get the fourth side. So 3 squared plus 3.98 squared equals c squared. And then so 9 plus 3.98 squared is 24.8404. 24.8404 equals c squared. Square root both sides, and you get 4.98. All right, it was supposed to be a 3, 4, 5 right triangle, but I rounded, so it's a 4.98, 3.98 triangle. All right, guys, I know that was long, but hopefully helpful. Post all your questions, ask all your questions, and we're going to have a great time this week. Bye, everyone.